can be taught in the class. This is just the introduction part of what machine learning is, and it is module number 4. Okay, so as we all have heard about the term machine learning, it is a part of AI. Nowadays, we are into the era of artificial intelligence, where we are trying to make the system think like a human and act like a human. Okay, so what is AI going to do? AI is going to provide missions the ability to learn automatically, and it also will help to improve completely. Everything will be handled by the machine, just like a human. For an example, if you could take a machine, when you type Google, when you give a search alphabet, search words, immediately it will give the search based on the ranks, which one was most frequently accessed, as well as which site has the exact match of the keyword that you asked for, will be shown first. Facebook, when as soon as you get yourselves attached with one of the friend, and the mutual friend between you both will be given a suggestion telling whether this is your friend. Because now, for an example, I have got introduced to a new friend, and we both have another friend of the same school. It will automatically suggest you have studied along with this new friend with the other person, and like that suggestions happen. So we'll be able to recognize the photos. If automatically the photos that we store in our mobiles itself is able to recognize the photos. Okay, asking, is this you? Is this so and so, etc. And to the machine is able to categorize whether this is a promotion, this is a social concerned data, or it is a primary in our mailbox. Okay, or it is a primary data, important data, or it is a junk or spam. All these details are being categorized by the machine itself. So machine is able to learn, and based on the way we access the machine, it tries to improve itself. Okay, so that is what machine learning is. So the main goal of machine learning is through learning algorithms and trying to mimic exactly what human brain is going to do. How human brain learns something, keeps in mind, and exactly replicates it. Okay, at when required, at particular instance, how to work on, how to explicit their behavior. Okay, so how will you make the machine to think or make decisions? So how are we going to make the machine learn and make decisions? So we are going to feed the machine with the data, and when we feed the machine with the data, it will learn. It will try to learn it, and it will understand how to interpret it, process it, analyze the data by various machine learning algorithms, and it will help to solve all the real world problems. So as a whole, if you could take artificial intelligence has a subset of machine learning, and deep learning is a subset of machine learning algorithms. So in machine learning, you will be using statistical methods to make the system learn, and in deep learning, we will be using neural network, multi-layer networks to make the machine learn. So that is what machine learning is. So what are the main terms that are used for machine learning? These are the terms that are used for machine learning. Number one is algorithms. So what are algorithms? A set of rules that will help the machine to learn. Okay, so we'll provide the machine with the data set and a set of rules, and based on the data set and the rules, the machine will try to learn and draw some insight. That is called machine learning algorithms. We have so many machine learning algorithms like SVM, support vector machines. All these are algorithms which will help, and we'll give a data set for these algorithms like random forest. All these algorithms will learn things and then try to infer some insights from it. So these are called algorithms. Model, main component of machine learning is the model. How are the model trained? By the machine learning algorithms, the model are trained. Okay, so if you could look at this picture, The problem statement is determine the type of the fruit. So how are we training the machine? This robot is trying to be acting as a machine now. So how are we going to train the machine? So we are going to give algorithms. It might be SVM, it might be random forest, so many algorithms. So we'll give the data set. See, this is a small data set. Okay, this data set is being given for the machine to learn. And how is the machine going to learn? The machine is going to okay, 1 minute. Okay, see, this is my data set. So from this data set, there are features. We call this as predictor features. What are predictor features? Features of the data used to predict the output. So this is my input data. So in my input data, there will be so many features like fruit label, mass, width, height, color score. All these features are, we also call them as a predictor variable, which will help to predict the output. So I'll be giving the data set. I'll be training my system with the algorithms, and the algorithms will learn things now, and my model is now trained to predict. So when I give any input variable, any new data, then automatically this machine will try to predict it, and it will give a response. What will be the response? Telling whether this is an apple or lemon or orange, whatever it is being trained with. Okay, so how are we going to train the machine? We'll from the whole data set. Now for here we'll have a simple data set, but you have already known, okay, from the whole data set, 75% of the data will be given for as a training data to train the machine. Okay, and from the machine learning from the 75% of the data tries to predict any input that we give. Okay, so when I give an input data, then that becomes the testing data to test and evaluate how my algorithm and model is working. Okay, so that will be the outcome of the machine learning algorithms. So these are the terms that we will be using. And how is machine learning going to help? What is the process involved in machine learning? We have certain steps to be followed to solve any problems using machine learning algorithms. So all the machine learning algorithms will help us to build a predictive model that will be helping us to come or find a solution for any problem that we have to address. Okay, so what are the steps to be followed? Number one, first we should know what is the objective of the problem. We have to define it, then gather all the data. After gathering, we do the preparation, that is data cleaning. Then we do exploratory data analysis for the data. Then we build the model. This is where the algorithms all will work. And then we will evaluate. After that, the prediction is achieved. Okay, so we will look into it one by one. What is called as defining the objective of the problem. How are we going to define the objective? We are going to tell this is my problem. If and when I have a problem with me, I should also know what will be the input data given to address this problem, and what should be the expected output I'm expecting. What will be the input variables or the predictors that I'm going to give for in this data. Okay, for this solving this problem as a data. What will be my target? So all these things, for an example, we were looking into Toyota car. Okay, so in my car data set itself, I to know the value of the car price, to know the value of the reselling price of the car, I should know how long the car has been, when it was purchased, what is the kilometer it's running, is it running on petrol or gas or diesel. All these are my input variables. What should be the target feature? Target feature should be, is it worth selling, the selling price? Okay, what price as on today this car is worth enough to be sold? That will be my target feature. So we will so I'll have to define the problem exactly. Okay, so what should be my input, what is the expected output, and what is the problem that I'm facing? I wanted to sell this car, so what all should be taken into consideration as input, and what should be my output? What am I expecting as the output? Okay, so what kind of problem to be solved? So we'll have so many ways to solve regression, classification, clustering. Okay, so when my data is numeric, then I go for regression. When my data is categorical, I go for classification, and I want to cluster things, okay, based on the categories and all these things, then I go for clustering. So I define my problem based on these type of algorithms. Okay. So next one is data gathering. So now I am clear with the problem that I should solve. Then for that particular problem, I should start gathering data. So getting data is one of the important step. I have to know where should I get this data from. Okay, because any real-time data will be much useful. So am I going to do it manually? Am I going to collect it, or am I going to in person? I'm going to go and collect it one by one, or through online methods I'm going to collect it. Okay, and because if I'm going to take a survey of 100 people or 100 students now, for every student I cannot go and gather all the data from 100 students. It is time consuming, but if that should be the case, then I should do that too. In online methods, there are various ways to download. Just all what we are doing is just downloading the data set. Those are all online methods of downloading it at one click. And web scraping, all these ways are trying to help or gather data from through the online methods. So this is one of the time consuming process, and it is one of the important steps in the machine learning algorithms, the data gathering part. Okay, so once the data is gathered, as we have already seen in our unit 1, the data what we have will not be a perfect data. We have to make it perfect. Okay, so it might not be correct. A few data are there might be misinterpretation in that. Okay, redundancy, inconsistency, all these. Sometimes the data's values will be corrupted, duplicate values will be there. Sometimes the data might be having unnecessary data that is not needed, wrong data, all these things will be there. So we have to do the cleaning part. So that is the data preparation part, because when I consider my data as such and I use my data as such, I don't think we will not be assured that all these data are perfect or perfectly correct. Okay, so when there is a wrong data will lead to wrong predictions and wrong computations only. So that is not going to help us solve the problem. So 80% of the time we work on is to clean the data. Okay, so once the data is cleaned perfectly well, then my processing takes only just 20% of the time. Okay, so that is how data cleaning is a time-consuming job, but it is also a very important job that has to be done with utmost care. Okay, after the data preparation and cleaning is done, we have to go for exploratory analysis. In this exploratory analysis only, we will understand the pattern, the trends. Okay, what is the type of the data? Is it in the correlation? We will find out, is these two features are positively correlated or negatively correlated, or there is no correlation? Is it having any outliers? All these informations with the features, okay, the predictors will be analyzed. So that will help us to come to a conclusion whether these two features will be helpful, whether these two variables will be helpful for our predictions. Okay, so that is the exploratory data analysis. After the exploratory data analysis done, we do the model building, where 70%, if for an example, where 75% if you take for training, then you should take 25% for testing. If you take 80% of your data for training, then 20% for testing. Okay, so in model building, our input data will be split into two parts, training and testing. And using the training data, we will train the model to predict the pattern properly. Okay, so that is what model building is. And the way we build the model and selecting which algorithms to work on this model is very important. Okay, whether it is going to be regression or classification or clustering. After that, we will be evaluating using our testing data. And if it is predicting the output correctly, then our model is trained perfectly. Otherwise, we have to retrain our model with different input and then make sure that the system is trying to predict the output correctly. That is called model evaluation. Okay, and it is giving us the output, and that output is helping us to make our predictions correct. Okay, approved. And we can keep on evaluating the model based on our predictions. So these are the steps for any machine learning process. What are the machine learning algorithms? Okay, so how are these algorithms or machine learning problems that can be put into categories? They are supervised machine learning algorithms, unsupervised, and reinforcement learning. What does it mean by supervised learning? Means supervised learning la, you will have all the data that are only labeled data. So you will have if 10 comma 4 comma 5 comma 6 is some data, this is the height, weight, breadth of a rectangle box. Okay, if it is going to be square, it will be 2 comma 2 comma 2 comma 2. So like that I'll perfectly label my data with my data and I label it. All my data will be labeled once. Okay, so it is easy for the machine to predict the output from the labeled data. Okay, the algorithms will learn to predict the output from the input data. The algorithm learns with an external guidance. External guidance as a machine learning analyst, we label the data and give it. Okay, so machine is only learning the data and the labels. Okay. So there is a need for an external guidance. But for the unsupervised learning, the data are not labeled. So they are all unlabeled data. And how is the data algorithm trying to learn? It will try to extract similar structures from the input, and it itself will try to predict, if all these are common, four sides are common, then it is going to be square. Two sides are of same size, horizontal and square, horizontal as well as the vertical part are having same values, then it is going to be a rectangle. So that is what unsupervised learning is. Okay, and what does it mean by reinforcement learning? The reinforcement learning will make the system to learn by it will automatically, the system will try to learn, and based on the errors it makes and the user correcting it, it will try to learn. That is called reinforcement. The machine will learn by itself after making many mistakes and correcting them again and again and again. Okay, so that is called reinforcement learning. We'll see few examples. If you could see here in this picture, there are various apples given. Okay, and those apples are all having supervised learning algorithms. Okay, all these supervised algorithms are helping us to get the machine trained. See here, all the apples are being labeled. The different pictures are labeled, and we make the machine learning algorithms to learn. Okay, so once it is being learned, so I have labeled all the data and I've made the machine to learn. And once it is learned, my machine learning algorithms are trying to predict now. Okay, so when I give my input, if I give one of this input, all these input, for example, here all the data is given again to the machine learning algorithm, and the algorithm is correctly predicting all these as apple and these two as not apple. They are not under the category of apple. We have given different apples, okay, and we labeled it. So any apple we give, it categorizes it as apple, and other things like these two, it is telling no, this is not apple. Okay, but it is not able to predict what is the fruit here. Okay, this is called supervised learning. If at all you take this picture, we are training the system with different types of donut. Okay, and during testing phase, this type of donut is given. Though there are different colors, different types of sprinklers, everything. During testing phase, when I give this, the system exactly tells it is a donut. That is called supervised learning. I train my machine with the help of labels. Okay, I tell this is what this is apple, this is orange. So all these I'll train my system. But if you could take the unsupervised learning, see how unsupervised learn. There are no labels. I don't label it as orange, apple, or anything. I just give all the fruits into the machine learning algorithms based on the size, height, weight, width. It automatically categorizes. That is how it differentiates the based on patterns, based on the size, based on the color. Okay, and it is telling these three are one category, category 1. These two are under category 2. These two are under category 3. So based on this, we will be able to know, oh, this is all apple, this is all plums, this is all orange. Okay, so that is what unsupervised algorithm. We are not giving any labels. System automatically predicts based on the pattern, based on the size, etc. Okay, so if you could see here, there are different balls given, and when the system is allowed to learn, after it learns, it predicts exactly these three are of same pattern, these two are same pattern. So one is baseball, one is football, the other one is basketball. It will be able to categorize things. Okay, so that is called unsupervised learning. what does it mean by reinforcement learning? If you could see here, in a reinforcement learning, the system is given. For an example, if you could see here, if you could see the system, this apple is given. Okay, system is telling it is a mango, and when it is when we are telling no, it is not a mango, it is an apple, the system keeps note of it, and next time when you show an apple, it will immediately give it is an apple. That means based on the response, based on the feedback, okay, the system will give a response, then as a user we'll give a feedback, and that feedback the system tries to learn, and after it learns, then it will next time when you give the same item, it will predict correctly. That is called reinforcement learning. Okay, we also call this as a penalty process, because how will the system, if when it is telling it is a mango, I'll not give +1 mark, I'll give -1. So automatically system knows, oh, -1, they are giving -1, so it is not a correct answer. So when it is telling it is an apple, then I'll tell +1, so I'm rewarding it. So that is how, based on the reward, it will try to understand things. And based on the penalty, it will learn, oh, this is not the correct thing that I have predicted. So that is called reinforcement learning. And these are the 3 types of learning. And what are the algorithms involved in the supervised, unsupervised learning is machine learning algorithms is what we are going to learn now. The complete unit deals with all these algorithms. One by one, we'll be learning all these algorithms. But today, I'll tell you the main how machine learning algorithms are classified. Okay, supervised algorithms are classified, and unsupervised algorithms are classified. Supervised algorithm is grouped into regression and classification. What does it, when I use regression models can be used when my target attribute is numerical, that is like to predict the weather level. Okay, so to predict the temperature of a human body. All these things are regression. When will I go for classification algorithm? When the target is categorical, that means whether to find out whether he is a male or female. This animal is a cat or dog. So that kind of classification, we'll use classification algorithm, because based on the categorical data, when the output should be a categorical data. In unsupervised learning, where we don't use labels, unlabeled data, there are 2. They are classified into or further grouped into clustering and association. What does it mean by clustering? Clustering means discover similar pattern. All these people are liking of movies, only movies. These set of people like only music. These set of people likes to read books. So, or these set of people purchase every month. These set of people purchase this item more frequently. So those kind of grouping based on a similar pattern is called clustering. Okay, and what is association? Association is when this person buys whoever buys mobile is more prone to buy the mobile case too. Okay, so people who buy X also will tend to buy Y. So that kind of association, because anybody who buys mobile will buy a mobile case too, to protect our mobiles. Okay, so that is the association. So at that time, we'll use association algorithms. So machine learning is being used for various applications, all these domains: retail, travel, health, finance, media. Okay, for filtering, for video surveillance, or fraud detections, spam, filtering the spam mails. Okay, web pages, taking tweets from the tweets, understanding their emotions. Okay, or search engines, every social media, or online customer supports, all product recommendation. Machine learning is used in everywhere. Okay, so these are few applications of machine learning. And where do we use supervised algorithms, that is regression and classification algorithms specifically? Okay, we'll look into that. Applications of regression algorithms are at weather forecasting, because there we will predict the temperature. Okay, the market analysis for predicting the stock, prediction of price in stock markets, etc. Okay, and the prediction of road accidents, number of road accidents due to rash driving, forecasting the real estate value. All these things, for all these kinds of problem statement, we go for regression algorithm. When do we go for classification algorithm? We go for classification algorithms when it is a categorical data. So whether this mail is a spam or not spam, is the credit card transaction correct, approved or not approved? Is the mass in the X-ray benign or malignant? Okay, is it cancer or not cancer? Is it a tumor or a not tumor? Like that. Okay. Banking, whether this customer will pay the loan or will not be able to pay the loan. Markets, any insurance, whether they will buy this insurance product or not. So all these kinds of analysis predictions, we have to use classification algorithm. When will we go for unsupervised algorithms? So in unsupervised, clustering algorithms will be used when we have to categorize the customers based on their behavior, purchase patterns, etc. Okay, and for example, biology, it can be used for classification among different species of plants and animals. If it is going to be used in libraries, clustering different books on the basis of topics, on the basis of technologies, etc. Okay, based on informations. Insurance, it is used to acknowledge the customers, their policies, and identifying the frauds. In city planning, in earthquake studies, whether these zones are dangerous or not dangerous zones, etc. Okay, so all these will help us to these clustering algorithm will help us to deal with these kinds of applications. Okay, so I'll show you one example of how this mission is working.
This machine is the first machine that will actually grade different types of produce on a consistent basis. So for example, one inspector might say that a certain package of strawberries is bad. Another might say that they're good. This machine will make the exact same determination every single time.
Today, over 50% of all fruits and vegetables goes to waste because of the inefficient and inaccurate distribution. So of 100 strawberries picked on the field, only 50 on average make it into the kitchen.
So the idea of inspecting groceries in an automated manner was born when machine learning and Amazon Fresh came together, and we were brainstorming ideas. If we, for example, could predict the quality of groceries, if we can predict if something is turning bad soon, also if we can make some statements about the taste, like if a strawberry is sweet or not.
The solution we came up with consists of an entire system with hardware and software, where the associates receiving fruits and vegetables in the warehouse will place the items on the trays, and it will go through a set of cameras and sensors that, combined with machine learning techniques, will be able to decide whether the items are good to be sold or not.
Right now, my team and I are actually teaching the machine to go through and understand what is a good piece of fruit versus a bad piece of fruit.
One of the reasons why research in this area is so important is that in food, in fresh food, the quality plays a very essential role to the purchase decision. This is only the beginning of the project, and the system will improve over time as we take more and more decisions and can integrate the feedback from our customers. And also, we want to expand the number of fruits and vegetables that we can inspect with the system.
Okay. So you would have seen, okay, how Amazon Fresh is working to make sure the data are the fruits, the vegetables, any a product is good or bad. So what type of machine learning algorithms are working here? Can anyone tell?